Good. What about you, Sadurshika? Okay. Anyway, I'll do this for Kamidu too. Kamidu is not joining. Uh, right. What you have to do is to multiply by the conjugate of this. No, going to finish, Sadurshika. Okay. Good. What you have to do first is to multiply by the conjugate. That is going to be the sum of these two parts. This one and this one. The sum of them. Okay. Then after multiplying it, mama ekaka parama ganna. Then the squares of these two, no, the squares of these two. Why? If you multiply by the conjugate, it should be the difference of two squares. So 4 plus 3 sin x minus 4 minus into minus here again plus 3 sin x over 2x times. Now you have to multiply by the conjugate. 4 plus 3 sin x plus the square root of 4 minus 3 sin x. Now you can simplify these two, cancel. 3 sin x plus 3 sin x, 6 sin x, right? 6 is here. Now you can take this 2 also out. Then sin x over x. Now you take like two limits. Another part. That's going to be 1 over the sum of these two. Then this part is going to 1. Here you can simplify 2 times 3. Then what about this side? Then 3 into the when x is going to 0, what about this sin x? It's going to be 0. Then square root of 4 is 2. 2 plus 2. Yes, 2 plus 2. 3 over 4. All right. Then Sadushika got the final answer, right? Okay. Right. We'll go for the next one. That's going to be 2012. Okay. X sin x. 2 sin squared 3x minus x squared cos x. You have to prove that it's 1 over 17. Okay, try x sin x over 2 sin squared 3x minus x squared cos x. Okay. You have to prove that it's equal to 1 over 17. Okay, do it and tell me. Okay. Got the answer, Sadurushika?
Yes, sir.
Yes. Good. Okay. I will do it again for others. Okay. Anyway, what you have to do is first you have to divide both the numerator and denominator by x squared. Why? Because you have to create here x. Then if you divide by x squared, you can get sin x over x part in the numerator, right? So you have to take like limit x is going to 0. Now here, okay, x sin x over x squared. You have to divide by x squared. Okay. Afla, did you get the answer? 1 over 17.
No, sir. Where to get the charger?
Okay. Now first you have to divide both the numerator and denominator by x squared, because you have to create sin x over x in the numerator. That's the reason why we divide by x squared. X squared වලින් divide කරන්න හේතුව තමයි මෙතන sin x over x කියලා part එකක් හදා ගන්න ඕනේ. Right? Then here you take 2, then sin squared 3x over x squared minus x squared cos x over x squared, like this. Now here x is simplified. Here x squared is simplified, cancel off. Then in the numerator, when limit x is going to 0, sin x of x is 1. Okay, so anyway you have to create like this, should be 3x squared, no? 3x squared, then you have to multiply by 9 to cancel them, because then only this part is going to 1. When limit 3x is going to 0, here x is going to 0. Okay, then 9 times 2 18 minus here when x is going to 0, cos 0 is going to be 1, then 1 over 17 is the answer. Simple එකක් lazy. මුලින්ම අර හිතන්න ඕනේ sin x over x part එකක් හදා ගන්න ඕනනේ. That's the reason why you divide by x squared. තේරුණාද අපලා?
Oh, sir.
Right. Sadoshika?
Yes, did.
Did. Oh, good. Okay. 2013 එක මොකක්ද බලමු. 2013. Shall I go for the next slide? Okay. Limits. This is 2013. One minus cos x over square root of 1 plus squared minus you have to prove that it's equal to half. 2013 A level. Okay, do it. ඔයාලට ලිමිට්ස් වල වෙන කොහෙන් හරි හම්බෙච්ච අමාරු ගණන් එහෙම තියෙනවා නම් මට කියන්න මං හදලා දෙන්නම්. ලිමිට්ස් වල විතරක් නෙමෙයි ට්‍රික් වල දැන් අපි කරගෙන යන ලෙසන් වල ඕනම එකක් වුණොත් මට කියන්න. Afla, good. So Darshita, half. You have to prove that it's equal to half. Good, good, very good. Both are okay. මේක කරන්න පුළුවන් මට හිතනවා ක්‍රම දෙකක්. Kamindi is also joining. Right. මෙහෙම හිතනවා දැන් if limit x goes to 0. Okay. I'm going to first now what is the conjugate of 1 minus cos x? Yes, there is 1 plus cos x. Then if you multiply the numerator and denominator,
Can't we that root 1 plus x conjugate of that?
I can't hear you well.
Can't we take the denominator as a conjugate?
Yeah, both conjugates. I mean, here also 1 minus x squared, then minus 1 plus x squared. Okay, mama may here sir. Right. Then here also it should be multiplied by the conjugate. 1 plus x squared plus 1 minus x squared, like this. And I'm telling now, if you multiply by the conjugate of the 1 minus cos x also, that is going to be 1 plus cos x. Then this becomes 1 minus cos squared x. Okay. Now minus 1 plus 1 cancel. Then 1 minus cos squared is sin squared x over 2x squared into you have to take both limits of when x is going to 0. Now 1 plus x squared plus 1 minus x squared over 1 plus cos x. Now if you take half out, this part is going to 1 into now in the second part, if x is equal to 0, root 1 plus root 1 is 2. 1 plus cos 0 is also 1. Now 1 plus 1 is 2. 2 cancel. Then the answer is half. Half කියලා නේද මේක පෙන්වන්න තියෙන්නේ. ඔව්. එහෙම නැත්තම් මං මේක අපිට ගන්න පුළුවන් half angles වලින්. 2 sin squared x over 2 කියලා. 1 minus cos x. එහෙම අරන් මේක then you have to multiply only the conjugate of the denominator. එතකොට මේක විතරයි මේක conjugate එකෙන් විතරයි multiply කරන්න ඕනේ. ඒ කියන්නේ numerator එක half angle විදිහට ගත්තොත්, if you take the numerators with the formulas of half angles, that is another method. Then you can do this 2013 this problem with two methods, by taking the numerator as 2 sin squared x over 2, that is using the half angle formulas, and or you can multiply by the both conjugates of numerator and denominator. That's also okay. Second method එක මම කියපු එක තේරුණාද? සමහරට එහෙම කරන්නත් ඇති ඔයාලා.
I did it that in that way.
In that way. You took that 1 minus cos x is 2 sin squared x over 2.
X over 2.
Right. It's okay. Afla, how did you do with the first method or second method?
First answer.
First one.
Yes, sir.
Yes, good. First one එකෙන් කරද්දී අර x over 2 කියලා එකක් එන්නේ නැහැ. ඒ කියන්නේ ටිකක් lazy. එතකොට අර නිකන් 1 minus cos squared x is sin squared x. Like that. But you can do like that in that way too. Both are okay. Same steps වලින්ම ගත්ත හැකි. ඕනනම් ඒකත් මම හදලා පෙන්නන්නම්. ඕනේ නැහැ නේ මෙහෙම ඇතිනේ. අර විදිහට කරනවා නම් 2 sin squared. එතකොට මෙතන you have to multiply only by the conjugate of denominator. like this. Then 1 minus cos x becomes 2 sin squared x over 2. You have to multiply by the conjugate of the denominator, 1 plus the square root of 1 plus x squared plus the square root of 1 minus x squared. Then the denominator becomes 1 plus x squared minus 1 minus into minus plus x squared, like this. Then plus 1 and minus 1 is cancelled. If you take this 2 out, now sine squared x over 2. Now the angle is x over 2. So this x squared plus x squared is also 2x squared. You can take that too. Then only you have x squared, no? X squared. Now we have to create x over 2 squared. Then x over 2 squared, but you have to multiply by 4 here. Am I correct? Yes. Then x over 2, you have to change the limit then. Keep in your mind it. This x over 2 goes to 0. Then this part becomes 1. Plus these two cancel into the limit when x is going to 0. 1 plus x squared plus 1 minus, no? 1 minus x squared, like this. This 4 is here into, now when x is 0, root 1 is 1, 1 plus 1, 2. Then these two also cancel. You get the answer as half. Both ways are okay. If you want to do in this way, do it. Or have a screenshot or something. Okay, both of you guys, no, all of you guys doing two different ways. දෙකෙන්ම කරගන්න. ඒක හොඳයි. මොකද එතකොට මොකක් හරි ඒවයි ගානකදී method දෙකම මේ වෙනවා. Okay, first doing this way and this way. Kamidu, you're somewhat late. I took that recording. I'll send you it, okay? Kamidu, can you hear me? We did 2010, 11, 12, and this is the 13. All of them were past paper questions. You take the second step at once, okay? You can simplify it with your own mind. Right, Sadushika, this side is okay, right? For you, because I flooded in this way, I think. Yeah. Sadushika, after doing this, tell me, and I'll show the next slide.
Yes, sir.
Okay. Afla, you do it this one, this method. Okay, Afla, good. Then we will do 2014. Okay. Tan squared 2x. X into 1 minus square root of 1 plus x. 1 plus x, not x squared. You have to prove that it's equal to minus 8. Limit x is going to 0. Tan squared 2x over x into 1 minus square root of 1 plus x. Right. Do it. Yes, why are you late? Done. Simple one, no? Yes, you have to multiply only by the conjugate of the denominator. 1 plus the square root of 1 plus x. Afla didn't get the answer. Another simple one. මට පේන විදිහට අපි හදලා බලමු x is going to 0 tan squared 2x x into, if you multiply by the conjugate, this becomes 1 minus 1 minus x. 1 plus the square root of 1 plus x, like this. Then minus 1 and plus 1 cancel. See, minus x into x, minus x squared. Then you can take this minus sign out. That will be easy. Minus limit into x. X is going to 0. On tan, then now the denominator is x squared. Here tan squared 2x. Then you have to create here 2. Then this has to be multiplied by 4, no? Into limits 1 plus square root of 1 plus x, like this. Now 2x is okay. I told you tan x of x is also going to 1 because tan is sine over cos, no? ඕනනම් එහෙම ලියන්නත් පුළුවන්. tan squared 2x can be written as sin squared 2x over cos squared 2x. Or you can take as a product of three limits. එහෙම ගන්නත් පුළුවන්. මෙතනින්ම එකපාරම 2x is going to 0 කියලා අරන් එහෙම 1 කරගන්න පුළුවන්. Now the answer is minus 4 into, here what about the second part? When x is going to 0, this becomes 0. Then 1 plus 1 is 2. That is going to be minus 8, like this. තේරුණාද? If you have got any problems, ask me. Right, done. Why problem at next week, next Sunday is going to be, I think, Haji, are you celebrating it, Afla?
What did you answer?
Next Sunday is Haji festival, right? Is it up to you? I'll take a
Then
Haji festival. I'm celebrate Kanan class.
celebrate කරන ඒ කවද්ද කියනවද දන්නේ?
I mean, next Sunday, in a Sunday. But එහෙනම් අපි day after tomorrow කරන්න පුළුවන් Friday. ඒ Sunday class එක කලින් කරමු ඔන්න. මොකද Sunday පුළුවන්ද නැත්නම් Friday කරමුද? Day after tomorrow. What about
Sunday recording එක කියවන්න පුළුවන්ද? Sunday කරොත් recording එක කියවන්න පුළුවන්ද sir?
recording එක නම් වෙන්න පුළුවන්. ඒ වුණාට live class එකේ ඉන්න තියෙනවා නම් class එකේ මොන හරි problem එකක් තියෙනවා නම් ඒක discuss කරගන්න පුළුවන්. Friday අනිත් අයට කොහොමද? කමිදු and සදෘෂිකා? ඇහුණා කමිදු මට දවස් දෙකම පුළුවන් ඔයාලට එහෙනම් මට බලලා කියන්නකෝ එතකොට differentiation පටන් ගන්නවා ඊළඟ දවසේ we are going to start differentiation using first principles and using formulas next Tuesday my differentiation යන ගමම while we are doing differentiation we are going to start VT graphs velocity time graphs in applied mathematics ඒ දෙකම එතකොට parallel යනවා applied පාඩමයි PO වල differentiation මේ දෙක balance එකේ ටක් ගාලා ඉවර කරලා integration කරන ගමන් applied වෙන පාඩමකටත් යන්න ඕනේ ටක් ගාලා අපි ඉවර කරමු ඒ ගැන බය වෙන්න එපා කොහොමත් අපි පටපට ගාලා කරනවා ළඟ දවස් දාලා හරිය මම ඒක අනිවාර්යෙන් කරනවා එක දිගටම දවස් 8 හෝ ඊට වැඩියෙන් හරිය දාලා අපි කවර් කරනවා කොහොමත් ඒක ගැන බය වෙන්න එපා right what about 2014 it's okay tell me hurry up or shall we go for the next one 2015 this is somewhat difficult මේක ටිකක් හොඳ ගානක් using the formula or using another method ක්‍රම දෙකකට පුළුවන් කියලා යාළම කියනවා what you have to find out is limit x is going to 0 x plus root 2 to power 4 minus 4 over sin 4x you have to prove that it's equal to 2 root 2 a good problem good question ටිකක් අමාරුයි පොඩ්ඩක් කල්පනා කරලා බලලා කරන්න බලන්න විනාඩි 10ක් දෙන්න හරි ටක් ගාලා කරන්න hurry up and do and tell me whether you got the answer or not okay ෆ්‍රයිඩේද සන්ඩේද කියන එක බලලා මට ඔයාලා කියන්න.
answer.
Yes.
අර ෆෝමියුලා එකේ
Uh,
එකේ තැනට x plus root 2 එක ගත්තත් කමක් නැද්ද? එතකොට ආන්සර් එක එනවා.
පුළුවන් පුළුවන්. මෙහෙමනේ කියන්නේ x plus root 2 is going to root 2 because x is 0 no. This arrow is also like an equality sign, right? Right. Then this should be x plus root 2 to power 4 minus this 4 is root 2 to power 4 no. 4 is root 2 to power 4. But there should be like x plus root 2 minus root 2 in the denominator. Then this plus root 2 and minus root 2 are cancelling off now. But x is remaining. Then you have to multiply by x. And this sign for x is here. Then again you have to multiply by 4. Here 1 over 4. Then this is n minus 1. You know, n minus 1. Right? N is 4. n is root 2. N minus 1. 4 minus 1. It is 3. එකපාරම ලියන්න පුළුවන්. මම එකපාරම ගන්නවා. It's going to be 3. n minus 1 into මේකත් වෙනම ලිමිට් එකක් විදිහට ගන්න මේක. එතකොට ඒකත් එකට යනවා. Then 1 over 4. And these are going to be cancelled. Now what about root 3 cubed? Yes, root 2 cubed. Root 2 into root 2 into root 2. Root 2 into root 2 is 2. 1 root 2 is like this. Step තව දෙකක් විතර ගන්න මේකට වෙනම limit එකක් ගන්න. For 4x is when 4x is going to 0. 4x over sin 4x is 1. මේ denominator එකට කරපු දේ තේරුණාද?
සිද්ධ කරේ.
මෙන්න මෙතන. අර ෆෝමියුලා එකේ විදිහට හදාගෙන ඊට පස්සේ වැඩිපුර වෙන x වලින් තමයි මේ මල්ටිප්ලයි කරන්න මෙතන. Then both formulas are used, right? n minus 1 and sin x over sin x is 1. Formula දෙකම පාවිච්චි කරන ගාන එකයි ටිකක් හොඳයි කිව්වේ. So anyway, in 2015 paper, we can find out some more difficult sums than the other years. ටිකක් අමාරු paper එකක්. අමාරු කියන්නේ it's difficult, but if you think a little bit, you can do. Problem නැති වෙනවා නේද? After doing this, tell me. Wait, Kamidu did. Okay. Afladan, right?
Yes, sir.
Yes, good. Okay. 2016. Let's see, 2016. It's somewhat different from other years. Okay. First, they are given that alpha is greater than 0. Let alpha is greater than 0. Then it's given lim x is going to 0. 1 minus cos alpha x over 4 plus x squared for minus x squared. It's given that 16. Find out alpha. Find alpha. Alpha is greater than 0. It's given. Then the limit and the answer is given. Find alpha. Okay. Try it. If you get an answer, tell me. 4. Afla says that alpha is equal to 4. Okay, let's see. I don't know the answer yet. Alpha is 4. What about other guys? මේ answer එක මාව නම් බලමු compare කරලා. මේකත් අර අපි ගානක් කර කලින් හැදුවේ in a previous question 1 minus cos alpha x. You can either multiply by both conjugates of the numerator and denominator, or you can take 1 minus cos alpha x as using half angles 2 sin squared alpha x over 2. The angle is going to be half, like this 1 minus cos alpha x. Or you can multiply by both conjugates, like no, you can't take it as a equality sign, like lim 1 minus I multiply by the the conjugate of 1 minus cos alpha x. That is going to be 1 plus cos alpha x. Then this becomes 1 minus cos squared alpha x. Over, okay, I write this 1 plus cos alpha x, and into by the conjugate of denominator, then this becomes 4 plus x squared minus 4 minus into minus plus x squared, and by the conjugate of that, square root of 4 plus x squared plus the square root of 4 minus x squared. It's equal to 16. It's given. Am I correct? 4. Sadurshika also 4. Then the answer will be 4. I think so. Okay. Anyway, we will do it. Now you take this part. X is going to 0. 1 minus cos squared is sin squared alpha x. Here minus 4 plus 4 cancel off. Then 2x squared. I take 2 here out. X squared can be taken here. Method x squared. Into limit x is going to 0. The conjugates 4 plus x squared 4 minus x squared over 1 plus cos alpha x. It's equal to 16. Now you have to create this alpha x. Then alpha x, again you have to multiply by alpha squared. I take it out. Alpha is a constant, no? It's a constant. So alpha squared. Now alpha x is going to 0. You change the limit. Then this part is going to 1. Then half alpha squared. Half alpha squared. When x is going to 0, this part is going to 0. Then square root of 4. 4 is 2. 2 plus 2 is 4. 4 over 1 plus cos alpha x. If x is 0, cos alpha times 0 is 0. Cos 0 is 1. 1 plus 1 is 2. That's going to be 16, right? Yes. Okay. Shall we simplify? 2 times 2, 4. Alpha squared is 16, but it's given that alpha is greater than 0. Then alpha is equal to 4. Very good. You can the method in alpha squared is 16. Then alpha should be plus or minus 4, no? But it's given that alpha is greater than 0. Then alpha is going to be 4. Good. Very good. කමිදු තේරුණාද?
ඔව් සර්.
රයිට්. හදාගන්න මටක් ගන්න. Right. Or someone can take this 1 minus cos alpha x as what? 2 sine squared alpha x over 2 using half angles. You can use two different methods. Right, Kamidu, done?
Yes sir.
Yes. Next side. Okay, no, you can simplify it now. Right, 2017. Alpha is between, it's given that here 2017. Alpha is between 0 and 5/2. Alpha is an acute angle, it's given. Prove that x is going to 0 or alpha. X is going to alpha. X cube minus alpha cube over tan x minus tan alpha. You have to prove that it's equal to 3 alpha squared cos squared alpha. Now alpha is a constant angle, acute angle. So this answer is not a variable because alpha is also a constant. X is not going to 0, x is going to alpha, right? X cube minus alpha cube over tan x minus tan alpha. Try to do it and tell me. Right, Sadurshika, you did good. I think this also can be done in both different ways. I see it. You can use the formula when x is going to a na n minus 1, or you can factorize this x cubed minus alpha cubed. Okay, I'll do it in a different ways, like this. Like limits x is going to alpha. This can be done like x cube minus alpha cube. මම මෙහෙම ලියා ගන්නම් මොකද now tan x is sin x over cos එකත් මම ලියලා ඉන්න sin x over cos x minus sin alpha over cos alpha. Okay, x cube minus alpha cube. Right, then this is going to be x is going to alpha like this, x cube minus alpha cube into, we should cross multiply the denominator, right? Sin x cos alpha minus cos x sin alpha. What's that formula? Yeah, when you cross multiply in the denominator, yes, sin x cos alpha minus cos x sin alpha, yes, sin x minus alpha. Can you remember it? Sin x minus alpha over cos x cos alpha, cos x cos alpha, the common denominator. Okay, I'll take this side, and okay, now x is going to alpha, right? Limits. Now you can do like this. Now sin x minus sin alpha, here sin x minus alpha, right? Then if you divide by x minus x over alpha, like this, then the numerator also should be divided, x cube minus alpha cube over x minus alpha. You have to divide both the numerator and denominator by x minus alpha. Here x is going to alpha into now here cos x cos alpha is going upwards. I know numerator. Then take a venom limit tech limit when x is going to alpha, cos x cos alpha, cos x cos alpha. Now when x is going to alpha, the numerator, you can apply the formula na n minus 1, na n minus 1. This n is 3, na a is alpha, n minus 1, 3 minus 1 is 2, 3 minus 1 into here when x is going in the denominator, it's okay, it's going to 1. වෙනම limit දෙයක් විදිහට ගත්තත් කමන්න තව step එකක් දාලා here when limit is x is going to alpha, cos x is going to cos alpha into cos alpha. Then the answer is going to be 3 alpha squared cos squared alpha by cos alpha into cos alpha is cos squared. මේක තමයි ලේසිම ක්‍රමය හදන්න තියෙන. තව ඕනනම් අපිට මෙන්න මේ x cube minus alpha cube කියන එක factorize කරලා ගන්නත් පුළුවන්. මම එහෙම කියගෙන ඉස්සර මේ විදිහට ගන්න. Sadushika, how did you do?
Like factorizing.
After factorizing, okay. This one is a somewhat beautiful method. Afla and Kamidu, what about you guys? No problems? Yeah, Honda Gana.
No, sir.
No. Kamidu? අර ෆෝමියුලා එක විදිහට හදා ගන්න ඕනේ. ඒ කියන්නේ තියරි දෙකක් තියෙනවානේ. When x is going to alpha, x to power n minus alpha to power n over x minus alpha. That's going to be na n minus 1. That's the principle of the differentiation too. Differentiation වලත් මුලින්ම ඕක තමයි අපි ඉගෙන ගන්න. Done. Okay, good. Santoshika, right. Done.
Oh, yes, sir.
හරියට. එහෙනම් අර අනිත් මෙතඩ් එක ඒ කියන්නේ මෙහෙම මම කිව්වේ සදුරුෂිකා කිව්ව x is going to alpha. X cube minus alpha cube, you can factorize it. X minus alpha, yeah, x squared plus x alpha plus alpha squared. The denominator is going to be like that. මම ඒක ටක් ගාලා ගන්නම් මේ cross multiply කරලා ඉන්න නැතුව sin x minus alpha. That denominator is going upwards, cos x cos alpha into cos x cos alpha. Now you can take like x minus alpha, x minus alpha over sin x minus alpha. එතකොට මෙතන you can change this limit, like now x is going to alpha, no, then x minus alpha is going to, yes, 0. You change the, when x is going to alpha, x minus alpha is going to 0, then only this part is going to be 1 into limits. Here it's okay, x is going to alpha, x squared plus x alpha plus alpha squared into cos x cos alpha. Am I correct? Okay. Now here it's going to be 1. When you substitute this x as alpha squared plus x into alpha. Now x is alpha, alpha into alpha is alpha squared plus again alpha squared into cos alpha into cos alpha cos squared delta. Here it's going to be 3 alpha squared cos squared delta. That method is also okay. I skip some steps. When you do it with the steps. With here lazy, they come okay. Okay, anyway, do this way to make up this is going to be the last sum we do for today. Then you can try for 2018, 19, 2020, 21, not 22. Okay, what will be the sum in 22? See. Okay, after doing this, tell me. Done. Okay, after. Sadushika did in this way. Okay, good. Now, see, are there any problems with the previous sums we did today? No. You can use here like in this sum. The method that we used was using the formula, right? For that, you had to do some changes, but you can factorize this, the numerator, like x plus root 2 to power 4 minus here it's root 2 to power 4. Now you can factorize this like okay, I write only the numerator. How to factorize this? Yeah. First, difference of two squares like this. The square of a square minus square of a square like this. Then again you can factorize using difference of two squares and simplify and take the answer. This is also another method.
Yes, sir.
Yes, good. You tried in that way too at home. So anyway, we are going to finish for today. I think no problems with previous sums we did. Am I correct? You have to try for 2018, 19, and the other past paper questions. And if you find any problem, let me know. Shall we do on Friday, because we are going to start differentiation, so a theory part. So if you are in the live class, I think it's better. What about other guys? If we do in on Friday, Hamindu?
Sir.
Puluhan, ne?
Yes, sir.
All right. Sadushika, what about you?
Answer.
Puluhan, ne?
Yes.
Yes, okay. Then after we will do day after tomorrow, we will start differentiation, and next Tuesday we are going to start VT graphs, and both lessons are going parallelly. Okay. Then we are going to stop for today. Have a nice day and work hard. Okay. Goodbye.
Thank
Thank
you,
you, sir.
sir.
Good night, sir.
Good night. Good night.
Thank you, sir.
You're welcome.
Thank you, sir.
You're welcome.